In fusion welding, metal coalescence is created by melting a base metal and filler metal together, or by melting the base metal alone. The principal fusion welding processes are arc welding, resistance welding, laser beam welding, and electron beam welding. Arc welding processes use an electric arc as the heat source to melt and join the base metals. The arc is struck between the workpieces and the tip of an electrode. Arc welding electrodes are usually consumable, but can be non-consumable. The consumable electrode is usually wire or rod, and the current that sustains the arc also melts the electrode so that it supplies filler metal to the joint. The electrode may also produce a slag covering to protect the hot weld metal from oxidation. The most common non-consumable electrode is a tungsten rod, which carries the electric current. If a welding operation using a non-consumable electrode also requires a filler metal, it is supplied by a separate wire, rod, or consumable insert. While welding, the electrode is moved either manually or mechanically along the joint, or the electrode is held stationary and the workpiece is moved. Arc welding encompasses a variety of processes, the primary types being shielded metal arc welding, submerged arc welding, gas metal arc welding, flux cord arc welding, gas tungsten arc welding, and plasma arc welding. Resistance welding processes produce coalescence of overlapping workpieces with heat generated by the resistance of the workpieces to the flow of electric welding current and the application of pressure. Resistance welding is primarily used to join sheet metal stock, but is sometimes used to join thin plate. All metals which can be fusion welded are weldable by resistance welding. Resistance welding processes use copper electrodes. These electrodes perform 4 functions. They conduct the welding current to the work and, in some cases, fix the current density in the weld zone. They transmit a force to the workpieces. They dissipate some heat from the weld zone. And they maintain relative alignment and position of the workpieces in some resistance welding operations. Very high electric currents are used to quickly produce the resistance heat necessary for fusion. The 3 principal types of resistance welding are spot welding, seam welding, and projection welding. Spot welding refers to making welds one at a time between the electrodes. One, several, or many individual spot welds may be required, depending on the application. Spot welding, with the electrodes maneuvered by articulated arm robots, is commonly used to join sheet components of automobiles. In seam welding, coordinated pulses of electric current from rotating wheel electrodes produce a series of overlapping spot welds, resulting in a leak-tight welded joint. In projection welding, the welds are localized at predetermined points by projections, embossments, or intersections. Several points may be welded simultaneously.